Hello, let's continue our Sudoku adventure with Shoot to Kill by Gene. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. I'll go over fog in a second, but we also have killer cages in the grid and arrows and a variant cage rule. So let's go over all of that. So first of all, the dotted lines here are the cage, and they always cage some number of cells. First of all, digits can't repeat in a cage, so that's not important for this one. But let's say we had a cage like this. I'm not going to fill in big digits, but if we had a cage that looked like this, normally Sudoku would let me put a 1 here and a 1 here, or repeat the digit here, right? But cages do not allow for repeats, and so this would not be allowed because of the cage, even if Sudoku does. All right, so you can't repeat digits in the cage, and additionally, the digits add to the sum in the top left corner, if given. So these three sum to 12. We also have arrows, and arrows, you see how we have an arrow here? They're always attached to a circle. And whatever the digits are on the arrow, they sum to whatever the digit is in the circle. So if this was, say, 2, 3, 2 plus 3 is 5, that would put a 5 in the circle. Again, I'm not using big digits because we have fog. I don't want to accidentally reveal anything. But we also have a variant cage rule. In this puzzle, each cage fully contains an arrow and its circle. So in every single cage we encounter, there will be an arrow fully contained by that cage. You can see it's exactly contained. I think we could have cages that are bigger than the arrow, but still fully contain the arrow. So the arrow doesn't peek out of the cage at all. All right. And then we also have fog in the grid. So most of the cells in this grid are gray because they're covered with fog. We reveal the fog by placing a correct digit. So let's say 2 was the correct digit here. That would reveal this 3x3 area, and we would be able to see what's underneath the fog in that area. And you're going to have to get correct digits. It kind of narrows your focus to where you're supposed to be looking. All right, cool. And so those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, so this is a fill-in. This circle's a fill-in. Why? Because we know that the 2 digits on the arrow sum to the value in the circle. Therefore, the total sum of all of the cells, the circle plus the arrow, is going to be 2 times the circle. And so we know that it's going to be 2 times the circle. And so we know that the circle is half the total sum. We know the total sum is 12. And so that puts the 6 here. And this is 1, 5, or 2, 4. All right, so that revealed a 12 cage here. I guess we could say there's a 3 in one of these 3. I don't know if that's helpful. So I bet we need to use our variant cage rule here because we don't see an arrow. So that means there's a fully contained arrow in this cage. Now we know that we're never going to get okay, let's say this was a 3-cell cage. I'm going to prove it can't be. We would need an arrow in here, and we know the arrow doesn't go here. So the arrow would do something like this, but that would mean this digit is the same as this digit. And no matter how the cage is drawn, you can't repeat digits in a cage. So we were not allowed to have only 2 cells occupied by an arrow. Every cage needs to have at least 3 cells occupied by an arrow. So we don't know how this cage is drawn, but we know that it's at least 4 cells in size. Now we know it can't be 5 cells in size because 1, 2, 3, 4, 5 would be the minimum in there, and that adds to 15, which overshoots the 12. So this is a 4-cell cage, and in addition to that, this is a even digit. So it's not the 3. Why is it an even digit? Well, because the arrow, again, the arrow plus the circle is always going to be 2 times the circle, which means it's even. And so let's say our cage was like, I don't know. Let's just draw a cage like that. Say our cage was like this. And then we had a circle, we had an arrow that did this, right? Just as an example. These sum to an even number, and we know 12 is even. And so therefore this digit here has to be even. So it's 2 or 4. And if this is 2 or 4, then over here we can't do 2 plus 4 is 6. We have to do 1 plus 5 is 6. And we know this is 2, 3, 4. Okay. Now we don't know this is how the cage is drawn, but let's think about the arrow in it anyway, because we just have to worry about let's not worry about stuff pointing down right now. Let's worry about how this arrow is going to work to get us to 12. So the minimum we could do is 1 plus 2, 1, 2, 3, which adds to 6. But that would require a 6 in here. And there cannot be a 6 in this cell. So it's not 1, 2, 3. So thinking about just this arrow, if it sums to 8, if the total thing sums to 8, then this would be a 4. And if the total thing sums to 6, This would be 12. This would have to be a 0. So, oh, 5. 5 would be the option. That has to 10, so that would be the 2. So our circle is 4 or 5. If it's 4, that requires a 1, 3 on here. And again, these could be anywhere. But if it's 4, not anywhere, but you know what I mean. This would require a 1, 3 here. So it would be 1, 3, 4, which adds to 8. And then we need another... Oh, that's the problem. If this is 4, that adds 8. That would repeat the 4. I didn't notice I said that. But yeah, if this is a 4, this sums to 8. How much more do we need from 8 to get to 12? We need 4 more, so this would also be a 4. So that doesn't work. So this has to be a 2. There we go. And now I can reveal what the real cage looks like, I guess. I was very wrong about where it is. Interestingly, I think I put a circle where there is a circle, but not the right one. So we know this is the circle, right? We can actually draw this cage. We may reveal it in a second anyway. In fact, we are about to reveal it, so we don't need to. But yeah, let's clear out these 2s. So we know what this is, right? Because these need to add to 12 minus 2. These add to 10. And so this has to be a 5. There we go. And that's what we had already deduced. And so now we can't use the 2, so this has to be 1 plus 4. And this 3, 4 pair tells us the order, 1 and 4. Nice. Okay. We're getting there. This is a pair. The 2 and a 6. Now there's an arrow in this cage. The cage does not have a sum. How do I know that? Well, let's see. Could it do this? No. That's 7 digits. So I know it doesn't have a sum because the sum is always in the leftmost cell in the topmost row it occupies. Leftmost cell. So this is the top row. It's the leftmost cell. This is the top row. It's the leftmost cell. So this has to be where the clue would be if there was a clue. So we don't know the sum of this cage, and we won't. But it's going to be fairly large because it needs to fit at least a 3-cell arrow in it. Yeah, that's pencil. I need 1, 3, 5. Oh, and this can't be 1 or 5. So that's our 3. Okay. We gotta put an arrow somewhere in here. I wonder if that's going to be helpful. Let's see. We need 2, 6 here. Well, this can't be a 2. An arrow cannot add to 2. Because we know there are no 1-cell arrows here. And also we know it goes to here. This you can see the little stub. A little hard to see, but you can see the little stub is going out this way. So the arrow goes this way. And so we definitely aren't repeating the 2. But we know the arrows are fully closed by a cage, so they never repeat digits. So that's a 6, that's a 2. Well, this is pretty big. So this needs to be either 1, 5 or 2, 4. Which goes in that way. In fact, we know this is 2, 3, 5, and we know this is 1, 4, 6. There's an arrow in here somewhere. Let's see. So this cage also doesn't have a sum, and it's going to go to here. So maybe we should draw that. Just draw this cage here. It's going to end there. The reason I know it ends is because that's 6 cells. If you can't repeat digits, you max out at 6. What are these 2? Let's pencil that. We need a 3, 4 here. So 6 is used, which means we need a 6 in this row. It's here or here. Darn. I don't think I can do anything with that. This digit, whatever it is, needs to go in this box somewhere. It doesn't repeat in the column, doesn't repeat in the cage. So it goes over here. We know it's not a 6, but I don't know if that's helpful. Does knowing what these add up to, is that helpful? Or I don't know, maybe thinking about this one. Thing is, the cage can go down. This cage could have a sum if we go up to here. Is there more I can do here? There's got to be some logic about one of these that I'm missing. Is it the arrow in this guy? See, if this wasn't the circle, I don't think it can be 5. In fact, I'm sure it can't be 5 if it's not the circle. But if it is the circle, it can be 5. So I think this cage has, so if we start drawing this cage, let's just actually just use a different color for it. If we start drawing this cage, we know it does this actually. Because we have this little corner here. Yeah, because we know this cell's not in the cage, right? Because we have this barrier here. There wouldn't be a barrier there if this cell was in the cage. So our cage does something along these lines, and it could close off here or it could turn. You know what? If it turned, would we see? No, we would see the turn here in this cell. This cell would have the turn. This cell would have the turn in it, not this one. Pretty sure, yeah, because you see how the turn is fully enclosed in this cell. Okay, so we don't know if it. Well, it must continue. Actually, we know it continues because we can't fit an arrow here. So it continues at least out here, so we could fit an arrow along here. But I don't know where the circle is for our arrow. Oof. All that to say, I don't know what's going on. We know this cell's part of our cage. And I think it has to be on the arrow. I think we've got an arrow using at least 3 of these 4 cells. There's a 1-5 pair already in the cage. So this can't be 1 or 5. So it's 2, 3, 4, 6. If it were 6, our arrow would have to go this way and stop here, and there is no way to add to 6. And if it's 6, it can't be on an arrow. So it is not 6. Interesting. This 3, 4 has to appear in our cage, actually. So whatever this is, let's call that purple. We know it's different than green. Purple cannot go in any of these cells by Sudoku, and we know 1, 5 is not purple because purple's 3, 4. So purple's in one of these 2 cells, and it's in the cage, right? Purple has to be in this cage. Well, purple is either in the cage or it's not in the cage, which puts it here, I guess. Well, is that true? I haven't proven the cage is 6 long, so it could just be omitting the purple. But it's over here somewhere, but we know that by Sudoku. Oh, okay. I don't know. There must be something. Oh, let's call this yellow. This yellow 1, 5 doesn't repeat in our cage, so it's definitely not in these 3 cells. And it's not this 2, 6. So yellow is one of these 2, and it can't repeat in the cage. So if the cage continued here, this would be our yellow 1, 5, and this would be our purple 3, 4 then. Or this could be the purple 3, 4. Darn. What am I trying to do with all this? I'm wondering if there's something a lot easier that I haven't noticed. We're 10 minutes in already. So we have a 1, 5 pair. 2, 6, where does 2, 3, 4, 6? I think this can't be 6. Okay. Oh, right. Okay. I know this is a 5 lane. I know that the cage has to end. Okay. This is interesting. Let's get rid of these colors. I don't think I need them. Let's talk about this guy. We'll use purple because it contrasts well, I think. You know what? Green might be better. Let's call it green. Green cannot be in this cage. No matter how far the cage goes, it can't escape this row. And this is already in the row, right? So if green was going to be in this cage, it would be here, but this can't be green because it can't be 2 or 6. Therefore, if there is a digit missing from the cage, and in fact it's this green digit that's missing from the cage, it has to be 5 big. It can't be 6 big, which means it ends right there. Okay, so we've proven where this cage is. So there's an arrow sitting here somewhere. If this is a good contender to be our arrow, because we could have this be 5, and then this could be 2 plus 3. So that's one option. We know that this is not our arrow because arrows don't do this. That would be 2 different arrows. So if this was our arrow, it wouldn't be the 2. So it would have to be 3 or 4. It would have to be the 4, and then we'd be 3, 1. So is this always 3 then? I think this is always 3, because if the circle's here, this is 5, and we need to do 3 plus 2. It's the only way to do that. And if the circle's here, it can't be 3, because this would be 4. So it would be 4, and this would be 3 plus 1. So this is always 3. And then now we know that this goes 4 and 1. There we go. Phew, got there. Wow, that was that took a lot of thinking, but that was fun. So I don't need any of this drawn anymore. So we have it fully revealed. This was key. This 2, 6 here was key. All right. So we're down to 2, 5, 6 over here. 5 is one of these 2. This is 1, so this has to be 5 to get us to 6. right, revealing more. So we still have to fit a 3-cell arrow in this cage. So let's do as much Sudoku as we can first, actually. 1, 2, 3, 6. This isn't 1 or 6, not 1 or 6. Yeah, this is a 2-3 pair for a cage, right? So that makes this 6 and 2. These are not 2s. That's not a 6 or 2, 3. So that's a 1. Okay. Yeah, this cage is quite limited where it can go. Huh. Is there more Sudoku I can do, or do I need to think about the cage? Let's see. 2, 3. Oopsie. 2, 3, 6. That's always the danger with fog, is it might reveal stuff by accident. So yeah, this is the 6 in this column goes here, so that reveals more. Okay, this cage has to use these 3, and this is where an arrow is, and it doesn't involve 1. So this is this is not the tip of the arrow. This is the arrow. This is the arrow, because this can't add to 3. There's no 1. So this sums to these 2, and they're all in this cage. And what do I need? Oh, I need a 6 in this column, but it's one of these. Okay. So I have 1. I need 2, 3, 4, 5. We're not 1 or 6. Okay. That's not a 2. This is a 2, 3 pair. So this is 4, 5 only also as well. So 2, 3 pair. Wait, what did I miss? A 1? Oh no, this could be 1. In fact, 1's in one of these 2. Okay. Anyway, I think I should think about this arrow. This certainly isn't 5, because this can't be 1. This can't be a 2. It can't be 3. It can't be 4, because it doesn't involve a 1, so it must be a 5. There we go. Okay. Got it. 6 and 5, 4 and 6. That's 3 and 2. We get the 3, 2 and 3. We get the 4 and 3, 1 and 5, 2 and 4. That's a 1, and we're done. Okay. Wow, that was a very interesting idea, Gene. I enjoyed that. It just took some doing. I just noticed this looks like a 1. I don't know if that's probably not intentional, but cool. This logic here of this digit not appearing in this cage, therefore it had to be 5 long. Therefore there was an arrow here or here. Either way, making that a 3, that was crazy. I don't know if there was another way forward, but I really liked that step. And then we used it again over here, of having to place a phantom arrow here, and there was only one way for that to resolve. Very interesting. Cool. Well, let me know how you did. If you enjoyed it, why not leave a like, subscribe, and a kind comment below.